Okay, in this video we're going to look at the ellipse. So the ellipse is the locus of a point that moves in a plane such that the sum of its distances from two fixed points in the plane is constant. The two fixed points are actually called the foci of the ellipse. So parabola has got one focus, and ellipse has got two. Parabola has got one focus, and ellipse has got two foci. Parabola has got one vertex, and ellipse has got two vertices. If this is the xy plane, parabola can, for instance, be oriented as an ellipse can be oriented as follows. So in this setup, you have a focus there at C0 and another focus there, F prime at minus C0, and then midway between the two foci we have got a center. Then this side we have got a vertex at A0, and then there's another vertex inside at minus A0. The axis along that cuts the two vertices is called the major axis. So here, for instance, this here is the major axis. It's going to be of length to A, and then this one here is the minor axis, is going to be of length to B. So this distance is going to be labeled B. So this distance from the center to the focus is C. Then if we do a right angle triangle here, then the hypotenuse is going to be A. So that means that three numbers A, B, and C have got a Pythagorean relationship, because B squared plus C squared is equal to A squared. Now, something else that we can deduce from this relationship is that A squared, A is always going to be bigger than B squared, because in order for you to get A squared, you add C squared to B squared. So A is always bigger than B. Okay, then so if this is the x-axis here, and this is the y-axis, and the center is at the origin, the equation of the ellipse then is going to be x squared over A squared plus y squared over B squared is equal to 1. You can see this equation is such that if you make y0 here, then it's going to give you x squared is equals to a squared, and so x is going to be plus or minus a, which are these 2 points here. Alternatively, make x the 0, then it's going to give you y squared is b squared. If you know this is 0 minus b, and that's a 0 b there. So that's the major axis, horizontal, and the ellipse is centered at the origin. Now, if the center of the ellipse is not at the origin, so imagine that the center of the ellipse is now at HK, but the major axis is still horizontal and it's of length 2a as above, and the minor axis is of length 2b. So basically everything exactly the same, except that the ellipse has now been translated so that its center is at HK. Then all that's going to happen in this equation here, every x is going to be replaced by x minus h. Okay, and y is going to be y minus k, and so that's what the equation is going to look like. All right, the eccentricity is a measure that tells us how much the ellipse has deviated from a perfect circle. Eccentricity E is equal to C over A. In terms of just A and B, then this is going to be square root of A squared minus B squared all over A. So from here you can see that A is always going to be bigger than C, so that means the eccentricity here is always going to be a fraction. When the eccentricity, or if the eccentricity is 1, then we have got a perfect circle. Then the ellipse has got 2 directrices, just like we did have for the parabola, and they are on the 2 sides of the vertices opposite to the foci. So again, the vertex, there's a focus here, and then this side we have got the directrix. Now the distance from the center to each of the directrices is going to be given by A squared over C, or this can be written as A over E. So that is from the center to the directrix. So that's about it in terms of an ellipse with its major axis horizontal. Now, if the major axis is vertical and the ellipse is centered at the origin, so if the ellipse is oriented a bit like this, let's try ellipse is oriented a bit like this. All the lengths are the same as before, so this time it's going to be x squared over b squared plus y squared over a squared equals to 1. Remember, this one is always bigger than this one. And then if the ellipse is the measure axis is vertical and the center is at a point different from the origin, let's use HK again, then this equation is going to change to x minus h all squared divided by b squared plus y minus k all squared divided by a squared. Alright, so that's about it in terms of the theory. Let's look at some examples. Yeah. Right, in this example, we're going to find the coordinates of the center for psi and the vertices for each ellipse. We're going to find the length of the measure and the minor axis. We're going to find the eccentricity, and finally we're going to make a sketch. By the way, before we continue, these are the standard forms of the equation of the ellipse with vertical measure axis, and here these two are the standard form if it's the measure axis is horizontal. The general form is going to take the form x squared plus ay squared plus bx plus cy plus d equal to 0. To go from the general form back to the standard form, again we complete the square. So this is the general form. All right, so in A, the equation is already in standard form anyway, so we just need to read off a squared and b squared. Find C. Remember, a squared is always the bigger one, so that means this is a squared here. So a is equals to 4, b is equals to 2. Then C is always the square root of a squared minus b squared, so it's going to be 16 minus 4, so C is going to be square root 12 or 2 root 3. Okay, now since a squared is dividing the x term, it means the measure axis is horizontal. Okay, so our ellipse is going to be oriented a bit like this. The vertex is at the origin. The foci will be at distances 2 root 3 from the origin, so one focus here and the other focus there. The vertices are going to be at distance plus or minus 4, so one vertex here, another vertex there. And then of course the coordinates of the center it is at 0, 0. The measure axis has got length 2a, so that's 8. The minor axis has got length 2b. Now remember b is 2, so that is 4 minor axis. Alright, we already have the sketch. Or the last thing we need to do is the eccentricity. The eccentricity is c over a, so it's going to be 2 root 3 over 4. It's going to be root 3 over 2. Alright, and that is that. In b we have got 25x squared plus 9y squared is equals to 25. So 25x squared 9y squared is equals to 25. First thing I want to do here is I want to divide both sides by 25 to get this to standard form equal to 1. So then this is x squared over 1 squared plus y squared over 25 over 9 equal to 1. So that means a squared is 25 over 9, so a is 5 over 3. B on the other hand is 1. So c, which is a squared minus b squared, is going to be 16 over 9. So it's going to be 4 over 3. So that's going to be C. Now the vertex is going to be at the origin, but because the a squared is dividing the y, the measure axis is going to be vertical. So the ellipse is going to look somewhat like that. Foci there, vertices there. So that means the foci will be at 0 plus or minus 4/3. The vertices will be at 0 plus or minus 5/3. The eccentricity is c over a, so is 4/3 over 5/3. It's going to be 4 over 5. And we already have the sketch. The major and minor axes. So the major axis is 2a. A is 5 over 3. So that's going to be 10 over 3. B is 1, so 2b is just going to be 2, which is the minor axis. Okay, that brings us to the end of the second example. In example number C, we've got an equation in general form. So in C we have got x squared plus 9y squared plus 4x minus 18y minus 23 equals to 0. So we need to convert this into a form like this one. Okay, so again, like I said, to do that we complete the square. So that's what we're going to do. So first we collect the x terms together and we bring the y terms together. The constant we take to the right hand side. Then in the terms involving y, we're going to have to factor out 9. Okay, so this is going to be y squared minus 2y. Now we can complete the square. So completing the square here is going to be x plus 2 all squared. Then that is going to necessitate adding 4 this side. Then here we complete the square inside the brackets is going to be y minus 1 squared. Okay, ordinarily we're supposed to add 1 this side, but everything inside here is multiplied by 9, so that means we add 9. Then that's going to be 36. So we have got x plus 2 all squared plus 9y minus 1 squared is 36. Then we need the right hand side to be equal to 1. So we're going to divide everything by 36. So we're going to have x plus 2 square, x plus 2 squared over 36. Then this one is going to be y minus 1 squared all over 4. Then you can see that this one is going to correspond to a squared because it's the bigger. This one is going to correspond to b squared. So c is going to be square root 32, the square root of this minus this. So c is 4 root 2. Now, since the a squared is dividing the x term, again what this means is that the major axis of this ellipse is going to be horizontal. But before we get there, let's do the coordinates of the center. So the center is going to be at minus 2, 1, given by these two numbers here. And then from there we're going to do a horizontal. So basically if we just do the ellipse like this, then we are going to say the center is minus 2, 1, right? And then if we go from here to here, distance of A, so A is 6, this side again A, so that means this one, for instance, is going to be minus 8, 1. This one is going to be 4, 1. Okay. Then the foci distance C from the center, so that's going to be affecting the x coordinate. So one of the let's just say the foci will be -2 plus or minus 4 root 2, okay, to the x coordinate comma 1. So those are your foci, and the eccentricity is c over a. So 4 root 2 divided by 6 root 2 over 3. Right, we have the sketch. Let's just complete this sketch. Let's put some coordinate axes here. So so this is going to be something like this. So so this of course must be in the second quadrant. All right, now we're going to give you a chance to have a go at the last one here. Then you can check our answer later. So if you just pause the video, have a go at this, and then you can compare with what we've got when you press play. Alright, so for this one, if we start by grouping the terms first, take the constant to the other side. Then for the x terms, we're going to have to factor out 9 here. Then now we can complete the square. So here, not only would need to add 16 this side, but because we're multiplying by 9, we add 16 times 9, which is 144. Then complete the square here, we add 9, so that means this side is just 9. Dividing by 9, then we can see that a squared is 9, so b is 1. So that means the vertical, the major axis of this is going to be vertical because a is dividing y. And then the coordinates of the center, of course, is going to be -4, 3. The c is 2 root 2, and there is your eccentricity. And so the ellipse is going to be oriented a bit like this. Center is at -4, 3. And then if you add a to the y coordinate, that gives you one of the vertices. Take away a, gives you the other one. And then if you add c, gives you one of the foci. And then you take away c, gives you the other focus. All right, the eccentricity is going to be 2 root 2 over 3.